Hi, this is Algebra 2, Lesson 30. We're going to talk about deductive reasoning, Euclid, vertical angles are equal, corresponding interior and exterior angles, and 180 degrees in a triangle. We're starting on page 134. Deductive reasoning is the process of reasoning from a non-reversible statement called the major premise to a result called the conclusion. The major premise can be stated in an if-then statement, or your book sometimes is going to use an arrow that points in just one direction. So we could say if something is true about A, then something is true about B, or A leads to B. So this means that if A is true, then B is true. It does not say that if B is true, then A is true. Okay? Here's an example. If a quadrilateral is a square, then a quadrilateral is also a rectangle. So we could say if square, that would be our major premise. If it's a square, then it's also a rectangle. This is true because all squares are rectangles, but it is not reversible because all rectangles are not squares. Okay? A three-step deductive reasoning process consisting of a major premise, a minor premise, and a conclusion is called a syllogism. So we have a major premise, all squares are rectangles. A minor premise, the quadrilateral ABCD is a square. And then the conclusion, quadrilateral ABCD is a rectangle. Syllogistic reasoning can be tricky, and we must be careful. Consider the following syllogism. Number 1, our major premise is all poets are poor. Number 2, our minor premise is Roger is poor. And the conclusion they've drawn is Roger is a poet. This is not a valid conclusion because it reversed the major premise. Poets lead to poor. That does not mean that poor leads to poets. Okay? An argument is a valid argument if we reason correctly. A valid argument does not lead to a true conclusion if one of the premises is false. So here's another syllogism. All chickens have 3 legs. That's our major premise. Our minor premise is Henry is a chicken. And our conclusion is Henry has 3 legs. The argument is valid. We went in the correct direction. If all chickens have 3 legs and Henry is a chicken, we've gone in the correct direction when we say that Henry has 3 legs. However, the conclusion is false because the major premise is false. All chickens do not have 3 legs. Hopefully very few chickens have 3 legs. Alright, here's another one. Our major premise is, if it rains, I will go to town. Our minor premise is, it did not rain. Our conclusion is, I did not go to town. This conclusion is false because the reasoning process is invalid. The premise does not say what will happen if it does not rain. It only tells us what will happen if it does rain. So we cannot draw this conclusion from these 2 statements. On page 135, there's an article about Euclid on 135 and 136. You need to read that. It's very, very good, very well done, and it's very good information for you. For our purposes, we're going to talk about postulates. We've talked before about the difference between definitions and properties. Definitions are reversible. So if we have a pair of parallel lines, they must be in the same plane and they must not intersect. Theorems, axioms, and postulates are not necessarily reversible. For instance, if two angles are right angles, their measures are equal. But two angles whose measures are equal are not necessarily right angles. So postulates are similar to properties or axioms in that they are based on other rules and mixtures of rules and properties, and they are not reversible. On 136, there's a list of postulates that Euclid was able to deduce and wrote down. We are going to use these postulates this year, and you are going to use them even more extensively in geometry to prove certain things are true. So we are going to practice that with the statement that vertical angles are equal. We have talked about vertical angles being equal before, and now we can show that that is true using some of Euclid's postulates. In particular, we're going to use postulate 6, which says that things equal to the same thing are equal to each other, and postulate 8, which says if equals be subtracted from equals, the remainders are equal. If we look at these lines, we can see that x and y are supplementary. This angle plus this angle equals a straight line. So x degrees plus y degrees equals 180 degrees. We can also see that x and z are supplementary. So x degrees plus z degrees equals 180. We could continue around the circle and say that z and p are 180 degrees and y and p are also 180 degrees. If x plus y equals 180 degrees and x plus z equals 180 degrees, then according to Euclid's 6th postulate, that means that x plus y equals x plus z. Right? Postulate 8 tells us that if equals are subtracted from equals, the results are equal. So if we subtract x from both sides, we're left with y equals z. We can use the same procedure to show that x equals p. So we have shown that y equals z and that x equals p. And so we use these two postulates to prove the theorem that vertical angles are equal. All right, let's talk about another one. Corresponding interior and exterior angles. In lesson 1, we postulated that when parallel lines are cut by a transversal that is parallel to one of the lines, all of the angles formed are right angles, as we see here. So here we have some parallel lines. They're cut by a transversal because this line is parallel to this line. If this line is a right angle to this, if this line, the transversal is a right angle to this line, then it's also a right angle to this line, and this line, and this line, because of these angles are parallel. If the angles are not right angles, we have postulated that half of the angles are large angles that are equal, and the other half are small angles that are equal. The angles inside the parallel lines are called interior angles, and the angles outside the parallel lines are called exterior angles. So first of all, we've postulated that these large angles are going to be equal to these large angles. And the opposite angles we just also proved are equal. And that these small angles are also going to be equal. The next thing was interior angles are the angles inside the parallel lines. So here we have two parallel lines cut by a transversal, and here's this large angle, which is equal to this large angle, and we have this small angle, which is equal to this small angle. And these are the interior angles. Okay? The exterior angles are the angles that are outside the parallel lines. So here's our large angle, and our large angle, and our small angle, and our small angle. Okay? Angles on the opposite side of a transversal are called alternate angles. So this interior angle is equal to this alternate interior angle. Those two angles are equal. This exterior angle is equal to this exterior angle. So these two are alternate interior angles, and these two are alternate exterior angles. The corresponding angles, so if we just take this top, we have this angle and its opposite angle, which are equal. And this angle's corresponding angle on this line is this angle right here. So these two angles are corresponding, and these two angles are corresponding. Likewise, these two angles are corresponding, and these two angles are corresponding. Okay? So there's some vocabulary. We've had interior angles, exterior angles, we have alternate angles, and then corresponding angles. So these two angles are alternates. This angle is corresponding to this angle. Okay? We can also use postulates to show that there are 180 degrees in a triangle. We've talked about this for a long time in lots of math problems, that all of the angles in any triangle add up to 180 degrees. And we can prove that by applying what we know about transversals. So we're going to start off with any ABC triangle. If we extend the sides and pretend that's a transversal and this is a transversal, and they're going to continue to go at the bottom, and this is going to continue to go this way. Okay? So now we have two transversals that are crossing, and they're going to cross this line, which is parallel to this line. Okay? So now we have two parallel lines that are crossed by two transversals. Okay, so the alternate to A is going to be this angle right here, right? This angle right here is going to be an alternate to C. This angle right here is going to be an alternate to B. This angle A has a corresponding angle right here. So this angle A equals this angle. This angle C has a corresponding angle right here, because these are two parallel lines crossed by these transversals. Because this angle equals A and this angle equals B, and we can see that this angle plus B plus C are supplementary, we can see that angle A plus angle B plus angle C has to equal 180 degrees because their sum makes a straight line. Okay, this is how we use postulates to prove theorems. And that is it for this lesson. Try your practice problems. Let me know if you have any questions.